Okay, this is lesson 13.1b, dealing with sequences still, and we're still working on recursion formulas. And the formula that we just kind of finished up was called the recursion formula. If you remember, what I had is I had a to the n equals a to the n minus 1 plus 3, for example. It's called a recursion formula because each term is written recursively in terms of the terms that precede it. So because it has this, it's called a recursion formula. Now you don't have to understand the whole recursion, what it means, just be able to figure out how to do it. So this is example 4. Alright, I am going to give you the answer to the first number. So the first number we're looking at's answer is that there. Once we plug the first number, once we plug 1 into our formula, it's going to spit out a 4. Alright, we also know that our formula looks like this. And remember, this means the preceding number. And they also tell you that n is greater than 1. So that number for n can never be a negative number. Alright, so it tells us to start the sequence with the number 4. A of 1 equals 4. Okay, we don't even have to plug anything in for this. They're just telling us we're giving you the first number. The first number is 4. Alright, so now let's do 2. They want us to write the first 4 terms. 5. What is the previous number? 4. So we're going to put that in there as 4, and that's going to spit out a 20. So A of 2 is 20. Okay, A of 3 is going to be 5 times the previous number. A of 4 is going to be 5 times the previous number. And how many did we want? First 4. 1, 2, 3, 4. Okay, so that's it. So my sequence is 4, 20, 100, 500, and then it'll keep going forever and ever. Amen. Okay? Okay, so this next one is kind of what I was saying before. Sometimes they're going to give you the sequence, like they're doing in example 5, and they're going to ask you to come up with the formula or the general term that makes this work. Okay, so that's what I've got. So this involves some guessing. So let's look at the 4 first terms. Now when we look at these, we have to use the same formula to get this number, this number, this number, and this number. So if there are any numbers included in our formula, they have to be able to work here. Alright, so again, this requires some guessing here. So what I usually like to look at is the second number. And it's like, okay, so how do I get to that second number? I can do all kinds of things. I can take 2 plus 2 plus 2 plus 2, so 4 times. I can go 2 cubed. So I can do a whole bunch of things, but when I do a whole bunch of things, I've got to make sure that it will work for all of them. Okay, so just for an example, let's just put the right one down here. 2 times 1 gives me my first term. 2 times 4 gives me my second term. 2 times 9 gives me my third term. And 2 times 16 gives me my fourth term. Okay, so my problem is all of these numbers are different, and they can't be. We've got to come up with a formula where they're all the same number. Or, basically what has to happen is this is my first number, this is my second, this is my third, this is my fourth number. first, second, third, fourth number. So that means I have to have a 1 in my answer here, which I do, so that works. I have to have a 2 in my answer here, which these numbers don't count. I have to have a 3 and a 4. Okay, because the first, second, third, fourth number, they have to have the 1, 2, 3, 4 in there. So this can actually be written as 2 to the 2 squared, and this can be written as 2 to the 1 squared, 2 to the 3 squared, 2 to the 4th squared. So notice what we've got here is we've got a 1, 2, 3, 4, first, second, third, fourth number. So that means that these numbers right here are my n's. Okay? So that is actually my formula right there. So when I take my third number, I should get 18. 3 squared times 2. And my third number is 18, so that works. If I take my sixth number, that would be 72. Okay, so I can find like my 82nd number, whatever that is, multiply that out, and that gives me my 82nd number in this series here. So what I'm trying to do is find out which number is the first, second, third, fourth. Okay, so I have to have a 1, 2, 3, 4. I've always got to have this order. So something needs to go around these numbers here, 1, 2, 3, 4, to make it so I get these numbers when I put something in. So in this case, I've got my 1, 2, 3, 4. I squared each one. So like the 3, I squared it and got a 9. So the third number, how do I go from a 9 to an 18? I multiplied it by 2. So everything in these formulas has to be the same except the 1, 2, 3, 4. Okay, so these, yeah, it takes some guessing. Let's look at example 6. So example 6 is find the general term for the sequence. So we start with a 2, and then we get, help if I would write the right number, 4/27, 5/64, and then that goes on and on and on. Alright, so what I know is that I have to have a first, second, third, fourth somewhere in here. So I've got to have an n. So what I'm looking for is a to the n equals something in there with an n. So I've got fractions, so that means that my formula is going to have fractions somehow. So let me just give you the answer. Let's put it up here. Alright, so there's the answer that you're looking for. So what we did again is let's go ahead and write all of these as fractions. Now let's look for some things that are going on. This went from 2, 3, 4, and 5. So each one of the numerators went up. So this is the first number, and it's 2. So that's where they got the n plus 1. So the first number plus 1 is 2. The second number would be, a 2 plus 1 is 3. The third number would be the third number. That's what the n, remember. The n always represents first, second, third, fourth. So this is the third number, plus 1 is 4. That's 1, 2, 3, fourth number. 4 plus 1 is 5. So that's where the n plus 1 came from. Now they look at this in here. Alright, so if this is the second number, how do I get from the second number, the 2, to an 8? Well, they cubed it. And the third number, they cubed it. The fourth number, 4 cubed is 64. Okay, so whenever you have an n, that is just telling you which place this number is in. This is the fourth number. So 4 plus 1 gives me 5. 4 times 4 is 16 times 4 is 64. Using this formula then will give you these numbers when you put the first, second, third, fourth, or 1, 2, 3, 4 in for your n. Okay, that's it. This will be difficult. This will be challenging. You will get frustrated. That's why you have an answer key, so you can look at these and kind of get a feel for what's going on. I don't expect them to just jump out at you and be able to find the answer really easy. They're not easy. You're just going to have to dig around and play with them and talk to each other. It's a puzzle, trying to figure out which numbers actually work for these. So, in the homework assignment, numbers 1 through 24 should be fairly easy for you. You're just putting the numbers in, the first, second, third, fourth. Numbers 25 to 34, write the first 5 terms of the sequences. We've done those. That should not give you too much trouble, but the ones that are going to give you a hard time are 35 to 50. Those are the ones where you're doing what I just did on the screen right now, and those are a little bit trickier. So those are the only ones that are going to give you, I think, any kind of a hassle. I don't want to prophesy that you're going to have trouble, because you may not have trouble. You may find this is pretty easy, but I always had trouble with it, so I expect that you quite possibly will too. So anyway, you shouldn't have any problem. 1 to 34. But 35 to 50 will give you a little bit of a headache. So anyway, don't get too freaked out about it. Just do what you can with it and work hard.